This video will introduce the topic of graphing lines as well as writing equations of lines. Our learning outcomes will be to solve for a specified variable, as well as to manipulate linear equations into different forms. We will use the point-slope form to write linear equations. We will also use the slope-intercept form to write linear equations, and we should also be able to find equations of parallel and perpendicular lines. So let's talk about solving for a specified variable. In the last lesson, we saw equations with only one variable. Now there will be more variables in the equation, but we only need to solve for one. So when we have that situation, we need to treat all the non-specified variables as if they were real numbers. So we could still use the properties of equality in order to solve for our particular specified variable. And then we continue solving as if our specified variable, as if it were x, similar to the way we did it in the previous lesson. Though there are other videos that will do example number 4 for you, I wanted to make sure that we can manipulate linear equations into different forms. So for example, if we had the equation ax plus by is equal to c, and I asked you to solve for y, again, this is our specified variable, and we're going to move this to the other side of the equation. So we're going to add a negative ax to both sides. That's using one of the properties of equality. So that will give me by on the left side and a negative ax plus c on the right side. Then I'm going to divide everybody by b. We're assuming b does not equal to 0, and we are using our properties of equality, and we would find that y is equal to negative a over b x plus c over b. So I don't know if you recognize any of these equations, but this one is actually one we probably noticed more as y is equal to mx plus b, lowercase b, where m would be this part right here, and the lowercase b would be this guy from here, from our original standard form of an equation. So we'll talk more about that in just a second. So let's do an example like this, but using real numbers. So let's say we have 3x minus y is equal to negative 1, and I want you to solve for y. So we're going to move our 3x by subtracting 3x to both sides. We're going to get negative y is equal to negative 3x minus 1. Then I need to divide by a negative 1 or multiply by a negative 1. You make that call. I'm going to go ahead and divide, and I'm going to get y is equal to a positive. Don't forget, negative over a negative is going to give me a positive 3x. And again, this is going to give me a positive 1. So we have started with this form of a linear equation in two variables, and we solved this linear equation in two variables. The other thing that we can see, and we're going to practice that as well, is what if we had something that looked like y minus 7 is equal to 3x minus 2? Well, again, if we're solving for y, I'm going to have y is equal to 3x minus 6 plus 7. So I did two steps here. But one of the things I did was did the distributive property, so that's where I got my 3x minus 6, and then I also added 7 to both sides, and that's where I got my plus 7 here. So now I'm going to combine like terms, and I'm going to find that y is equal to 3x plus 1. So the big thing here that I wanted to show you was that if we had an equation in this form, or in this form here, or in this form here, all three of these equations are actually describing the same line. And so that's one of the things that we're going to be talking about today. Before we go into using the point slope and the slope intercept forms in order to write equations, let's first go over one of the handouts that I made specifically for this lesson. You should be able to find that in my notes. So let's go over some information about lines that you may or may not know. The very first thing I'm going to talk about is this very first equation that we have here. This is actually the equation of slope, where you're given 2 points. So I'm going to write down given points x1, comma y1, and x2, comma y2. So you're given 2 points, and your job is to find the slope between those 2 points. So you use this when you want to find a slope and you're given 2 points. And here's an example that you might see that would ask you to that would require you to use this equation and this information. If we go to the next one down here, this one is actually called the point slope form. And we actually use this when you're given 1 point and the slope of the line, and you want to use it to find the equation of a line. And you can see that over here. It says to find an equation of a line containing the 2 points, and we have these 2 points. Notice those are the same 2 points we had up here. So we would have found the slope over here, whatever number that is, and then we would have used that slope that we found here, and then pick one of these points. It doesn't matter which one, but you pick one of those points, and then we would use it into this equation. Again, your textbook supplies examples showing you how to do this. So I'm going to go forward and continue explaining this handout. This equation is what we call our slope intercept form. So you'll see me write it like this. And sometimes this is also known as the graphing form. Not always, but the reason why we talk about this being the graphing form is that it's really easy to see 1 point and really easy to see the slope given this equation. So when do we use this? Especially when we want to graph a line, because it's really easy to find m as the slope, and we know there's a point, and that point is 0, comma little b, where little b is what we call the y-intercept. Now you can see why we're calling this the slope intercept form, because it definitely gives you the slope with m, and it also gives you another point. That point is 0, comma b, and this is what we call the y-intercept. So if we were going to graph that, so I gave you an example here of something we need to graph. We can see that +1 is our point 0, comma 1. Had that been a -1, then this would have been 0, comma -1. So I'm going to plot that point, and then I'm going to come to my slope. My slope is a -1/2. So I always tell my students to think of it as -1 over 2. So that means I'm going to go down 1 and then to the right 2. Down 1 and then to the right 2. Down 1 and then to the right 2. And I do the same thing going the opposite. I can give the negative to the bottom. That means go up 1 and over to the left 2, up 1 and to the left 2, up 1 and to the left 2. And then you can see where our line is going to be connecting all those points. I've also put examples from the textbook on how to graph lines. You can find those under course materials. Moving right along on the next page on your My Notes, we can see that we have an equation in standard form. Standard form. I actually like this one because it'll actually tell you both x-intercepts and y-intercepts. So this is really good to use to find intercepts, and I'm going to show you that in just a second. So for example, if you want to find the y-intercept, let x equal to 0. If x is equal to 0, then I'm just solving this equation here, and I would find that y would be big C over big B. So that would be my intercept, my y-intercept. If I'm going to look for the x-intercept, then I let y equal to 0, and then I'm just solving ax is equal to c, so x is equal to c over a. So that's really cool, and making sure that you can graph a line if it's in standard form. So here's that example here. So I would let x equal to 0, and I would find y is equal to -2. And then I would do the opposite. Let y equal to 0, and then I would find that x is equal to 3. 1, 2, 3. And so I have 2 points. From these 2 points I can find the slope. I go up to and over 3, up to and over 3. Or I can go down 2 and to the left 3, down 2 and to the left 3, down 2 and to the left 3, down 2 and to the left 3. And again, you can see where my line would be connecting all of those. And then last but not least, I want to talk about these two types of equation. This is y is equal to b. This is a horizontal line, and it has a slope of 0. And it's always going to be in the form of y is equal to b. So you might want to think of this as OI to help you remember. So to graph y is equal to 3, I come on the y-axis to 3, and then I draw a horizontal line there. And that would be my line. When I have x is equal to a number, that is going to give me a vertical line. It's going to have an undefined slope, and it's always going to be in the form of x is equal to some number. I guess it should also be a number. And what that means to us, this would be a vux. So think of OI vux if you want to remember which one's which. When x is equal to -2, I go on the x-axis till I get to -2, and then I draw a vertical line here. Big thing to remember here is that horizontal lines have a slope of 0. Vertical lines have an undefined slope. Horizontals look like this. Verticals look like this. So coming back to my notes, and after we did that quick review, we can see that you're going to be able to use the point slope form, and this is our equation for that. Remember that you need at least 1 point and a slope. If you're given 2 points, find the slope and then use one of the points in the formula. If you're given a graph, just find 2 good points. And what I mean by 2 good points are the ones that are actually on the crosshairs of the grid. That way you can get a better accurate equation. When you use the slope-intercept form of a linear equation, you need a slope in the y-intercept. That's the easiest way to use it. However, if you're given 2 points, you can also use it, and the example will show you how to do that. If you're given a graph, you need to find 2 points and also find the slope between those 2 points, and that way you're back to the scenario that you have up here. Finally, let's talk about finding equations of parallel and perpendicular lines. I think the video does a really good job of showing you how to do it. My job is just to remind you that biggest thing that you need in order to come up with an equation of a line is a point and the slope. Because if you do that, then you can use the point slope form to find the equation. And then once you find the equation in the point slope form, you can convert it into any form that you want. Either the y is equal to mx plus b form, the slope-intercept form, or you can put it into standard form, ax plus by is equal to c form. And we kind of talked about how to manipulate those earlier in this video. Big thing to remember here is that parallel lines have the same slope, and perpendicular lines have what we call negative reciprocal slopes. So in other words, if the slope is a over b, then the perpendicular slope is going to be negative b over a. So these two are going to be perpendicular slopes. So if you're given a slope, then you need to change it into this format and then use a point, and then you can go on ahead and find the equation of the line. So you can see here I have written the negative reciprocal of the given slope. So use the given line to find the desired slope. So if they give you a line that says 4x plus 3y is equal to 7, then you can find the slope by solving for y, and we've talked about that. Move this over, divide by 3. And then once you have it in that format, so that's going to be negative 4x plus 7, divide everybody by 3, we can see our slope here. If you want a parallel line, make sure you use the slope of negative 4 over 3 and whichever point they give you. If you want a perpendicular line, then you're going to use the slope of positive 3 over 4 and whatever point that they give you. And that concludes this video.